Keith Rucker here at VintageMachinery.org. Guys, it's happened again. Another old derelict machine has followed me home and is going to start residing here at the Vintage Machinery shops. And I'm really happy to get this. This is a machine that I've actually had on my list of things that I've kind of been on the lookout for. I mean, not just out searching for a guy to have it, but you know, when one came up, I was definitely interested in trying to acquire one. And what this is it's called a marvel saw. It's made by Armstrong Blum, and it's a band saw that goes up and down. You can clamp work in here, and basically, when you turn this thing on, it will feed across your work like such. So it works very much like a traditional, you know, vertical bandsaw that just drops down. But on this one, you clamp your work to the table or in this vise here, and it will feed across there. The really cool thing about this bandsaw is that it's kind of a multi-purpose tool in that you can just pull this thing forward and use it like a bandsaw, like a regular bandsaw. You can just lock down the whole head, come in here and work, or you can use it to cut stuff. It's got a really long stroke. I'm not sure exactly how long, at least 12 inches here that it can cut across. The head on this thing tilts, so you can, let's see, move this whole head to 45 degrees. There's a scale over here. So you can cut angles with it real easily. It's just a really, really versatile machine. And again, something that I've been on the lookout for a while. This one popped up not too far from me this past week, and I made the decision to go and get it and bring it into the shop. And that is exactly what I've done. I have brought it into the shop, and to be honest with you, I'm not even sure if this thing works. I think it does. It was in a factory, and they were basically closing that factory down. All indications are that it's been used recently, so I'm keeping my fingers crossed everything's going to work out fine. This one actually has a coolant system built into it, and I've got some of that taken apart. I've taken the lid off the pan and cleaned that thing up. It was full of sludge and full of chips and stuff, and I went ahead and started getting that cleaned up. I've still got a little bit of work to do down there, and it's got some sides that come in here to catch the coolant, and most of that stuff's still sitting outside. Basically, all I've done is brought this thing home. I unloaded it. I went ahead and got a squirt bottle with some degreaser, squirted it down real good, took the pressure washer to it, cleaned it up, which is kind of my thing I do when I bring something new into the shop, particularly something that's been in a factory and is full of grease and grime, is I'll go ahead and just pressure wash it. And I know a lot of people say that, you know, they don't want to pressure wash their motors and stuff like that. Give it time to dry out. You're not going to hurt this stuff. I mean, obviously that's not something you want to do all the time, but you're not going to hurt it by pressure washing something, and I do that pretty frequently whenever I bring something new in. So this morning we're going to try to get this thing wired up and just try it out. I've got it on where I can move it around right now. It's on some rollers and a pallet jack, but I think it'll be fine to just see if we can get this thing going right here. So let me show you my first challenge. So like most industrial machines, this has a three-phase motor on it, and three-phase motors, most three-phase motors are designed where you can either run them on low voltage or high voltage, and the high voltage is typically going to be 480 volts in the US, or low voltage is 220 volts. And now most factories are set up to run on 480 volts. The advantage of running on 480 volts is basically you can run smaller wires to your machine. The motor's going to pull less amps than if you run on the lower voltage, 220 or 240 volts, whatever it is. My shop is set up on low voltage, on 220 volts. I don't have 480 coming into the shop. In fact, I'm running off of a Rotary phase converter, American Rotary phase converter that we've got in here that takes my regular 220 volt single phase, converts it to 220 volt three phase, and that's what I'm running stuff on. So we're going to have to change the wiring in the motor. Now, most motors are set up where they can run on either low voltage or high voltage, but you have to do some rewiring of the motors to do that. This one here got a sticker on here, 480 volts. I'm sure that's what it is, so we're going to go ahead and check this thing out and get it swapped over so that we can run it on the voltage that I'm running in my shop. How can you tell if your motor is a dual voltage motor? You look on the motor plate and it's going to show you the options here. Notice up here we got low voltage and high voltage, and there's a wiring diagram for the wires that come out of the motor. Now typically on a three-phase motor you're going to have 9 wires that come out of the motor. Basically 3 wires on each of the different inputs, and depending on how you configure those, as you can see how you tie those together in the motor, or in this in the pecker head down here where all the wires come out, that determines on what voltage you're running. So I'm sure that we got it set up on high voltage right now, and basically I need to pull those out. Those wires should be numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll just have to change the way they're tied together in there and go from there. Notice on here on the amps, you know, it says 5 amps / 2.5 amps, and what that's saying is on the low voltage it pulls 5 amps, this motor does. On the high voltage it's only pulling 2.5 amps. So we will also need to change the heaters in the motor starter. I haven't even looked at that yet to have it for the correct amperage that this motor is going to pull, because right now if it's on the high voltage it's going to be on 2.5 amps, and I need probably different motors or different heaters in there to adjust for that. This is a 1.33 horsepower motor, 3-phase, 60 cycles, all that matches 1800 RPM, but like I said, we need to change out the high-low voltage. So let's pull that pecker head apart and go ahead and take a look at that. So we'll take a screwdriver here and we're going to open up this pecker head. This is basically where all the wires come out of the motor and where you connect the wires that goes to your motor starter. And we'll see what we got. All right, so it looks good. The wires are marked. You see they all got the numbers on them. And I'm going to just pull all these out and confirm that it is indeed wired for the high voltage, and I can already tell it is by there's only 2 wires on each lead, which matches what's up here. On the low voltage, one set's going to have 3 wires in it, but if you look here, we have 6 and 9 are tied together, and I look here, 6 and 9 are tied together. This one is 3 and going to one of our inputs. 3 goes to the line. 5 and 8 are tied together. There's 5 and 8 tied together. So here's what we're going to do. We're just going to open all these up and get them to where I can just totally rewire this thing. So let me go ahead and pull all these wire nuts off, and we'll get it configured right. Okay, so we should have 3 inputs for our 3-phase lines. This is coming in from the starter, and these are all the wires coming from the motor. Now, first thing I want to do is 4, 5, and 6 get tied together. So let me find 4, there's 5. There's 6, and here is 4. So these 3 wires get tied together. We'll just put them together and we'll put a wire nut on there. We need to just follow the wiring diagram. And according to this, 3 and 9 go together. So let me find 3, there's 9, and here's 3. So 3 and 9 go together, and those get tied into one of my line feeds. So we'll go ahead and just put those together. I'll grab one of my line feeds here, and we'll put a wire nut on here and pull those together. Now, one thing I'll say is that it doesn't really matter which one of your line feeds go to which one here. You got 3 lines coming in. The motor may run in reverse whenever we first hook it up, but you can swap the direction, the rotational direction on a three-phase motor by swapping any two of your line feeds. You can just randomly do that. So we're not going to worry about that right now. We'll just check out the rotation, and if we need to, we'll swap one of the wires. All right, next, looks like 2 and 8 get tied together. So let's find those two. There is 8, there is 2. So we got 2 and 8. We'll put those together. Again, tied into one of our leads, one of our lines coming in. All right, and that should leave number 1 and 7. And that's what we've got here is number 1 and number 7. I don't know if y'all can see that, but I can. We'll tie those two together, and we'll put our third line on with those. All right, so that should be wired for low voltage now. Fairly easy. Anybody can do this as long as your wires are numbered and you have a wiring diagram. And by the way, the wiring diagram on these motors, I always look on the motor plate just to be sure, but they're almost always identical. But I'm always worried I'll get an old weird motor that may have a different number on here, but this is pretty standard on the way those are wired up. All right, so here's our enclosure for the electrical controls on here. This is your main switch. Whenever you turn it from on to off, it disconnects everything in there automatically. So really you can't open this box up without shutting the power off. At least the input you'll still have live, but it'll cut everything off to the saw. It's just a safety feature. And let's see, that's going to take a, we're going to have to get a wrench there and take that bolt out. Let me get that. So it looks like at one time there was another one of these clamps that screw everything together up at the top, but it is no longer there, which probably doesn't meet OSHA standards anymore. But fortunately for me, this isn't an OSHA shop. All right, let's see what we got in here. So let me zoom you in, I'll kind of tell you what we got. All right, so a couple things in here. First off, this is the motor starter down here. This is what actually engages the power when you hit the power button over there on the front of the machine, or the stop button. It has contacts in here that open and close. This is really the most important part of the whole system, and this is a safety feature. This is a magnetic switch, so that if the power goes out, it's going to automatically pop out. And there's basically a magnetic coil in here that whenever that's energized, it pulls some contacts together and allows the electricity to go through it. From that, it goes up to this fuse block. This is just making sure that we don't overload it. And let's see what size fuses these are. How many amps? I'm guessing that's going to be a 15 amp fuse. And I'm just sitting here looking at them. They all look like you can see the little fusible link in there that will burn out if you draw too many amps. And like I said, we're going to be on 5 amps is what this motor should pull when it's going full blast. So I think we're fine there. You'll basically bring your power in to the top of this up here. This will be where you feed in, and then that'll go down to the starter. Now we've also got a transformer in here, and this transformer steps down the voltage, and this is what's used on the control circuit. So we have the push buttons up on the front of the machine, and that's going to actually what energizes the coil whenever you hit the buttons in a certain order. And typically we don't like running those push buttons off of line voltage, because I mean, obviously if this thing was still hooked up on 480 volts, you would have 480 volts going to the buttons up there. So that would be a potential place you could get shocked. So basically this steps down the voltage that goes to the coil. And let's see what looks like a was at 110 volt coil. So we basically need 110 volts going to this coil. Now, because I changed the voltage around, I'm probably going to have to rewire this thing because we're feeding it with, it was before being fed with 480 volts and stepping it down to 110 volts. I'm now feeding it with 220 volts and going to need to step it down. So we'll need to probably change something on there to make that happen. I'll have to look at the wiring diagram and figure that out. And the other thing is the heaters. The heaters are these little pieces right here. This has an N, it's got an N16 on one side and N14 over here. There should be 3 heaters on this. We're going to need to change those out, and I'll have to look up and see what heater I need, and I'll probably have to order them. For today, I'm just going to leave those in there. But these are set to protect your motor. Again, at 480 volts, the motor only draws 2.5 amps. So this is designed where if it starts drawing more than 2.5 amps, that it's going to open up the circuit and basically collapse the circuit and shut the machine off. It's just to protect your motor. Remember, you know, I have a circuit breaker, but my circuit breaker that's feeding this is a 20 amp circuit breaker. My motor, when I get through, is going to be running at 5 amps. So this is just, you know, I don't want the breaker to trip when I get to 20 amps. I want the switch to trip whenever I get to 5 amps, because if I'm drawing more than 5 amps, that's more than what that motor is designed for, and you could damage the motor. So, and that's something else that takes place in your motor starter. We got some fuses over here. This is probably for our transformer. That's usually the way that works. And anyway, I'm gonna get in here and do some rewiring. Like I said, change the transformer around and figure out what heaters I need on there to switch this thing over to 220 volts. All right, I got you zoomed in here. Hopefully you can see this. This is the transformer. And right here on the front, there's a little wiring diagram. And I'm not sure if that's going to show up, but it shows basically 2 options, a low voltage and a high voltage. You got a wiring diagram for 220 volts and a wiring diagram for 440. Or it could be 240 and 480. I mean, it depends on your voltage. We often talk about 220, 230, 240. They're all, yes, they're different voltages, but most motors and systems, they can kind of work in between those different voltage ranges. I think mine is actually on 220. We're in a more commercial setting. It'd probably be like 240 or going to the 400 volt range would be 480. Anyway, I digress. But if you look on here, it shows for the high voltage option, there's 4 terminals on the top up here, 1, 2, 3, 4. And it shows your line voltage coming in, the 2 on the outside, and then it shows on the 2 front, the 2 middle ones, just connecting those 2 together. So to go to 220, what we need to do is take this jumper here off. When you put a jumper between this input one and this one, and this input and this one, and that will change the windings inside this transformer to change the voltage. So if I were to just go with this right now and put 220 volts into this instead of 440, out the bottom, instead of having 110 or 120 volts, it would be giving me half of that. It'd be giving me, 60 volts. So, you know, I need to get 110 volts out of the bottom, or 120 volts, again, depending on the input voltage. So I'm going to pull this jumper off right here. Those are actual, they're not spades, they're loops, so I have to pull the screw all the way out. Okay, and I'm just going to move it back to this one, and then we'll make another jumper to go the other direction. All right, let me go make a jumper, and we'll connect that other one up. All right, guys, real simple. I just made a jumper here. Just took a piece of wire, put a couple terminals on there, and we're going to start by putting this back one on. So this has the input voltage coming into it. And then we'll come in here and put this second one up here. And there we go. Our transformer should be properly wired. So now we just need to get us a new cord. They pulled the old cord out so we don't have any incoming power. Get our incoming power in there and we can plug it up and try it out. So I've got my cord coming into the machine now. We just came in an existing conduit fitting over here or cable fitting over here, and this is a brand new what's called SO cord or service cord, 4 wires in it, and I need to pull back the insulation on the outside. Now I've got one of these little cool wire stripping tools here that really makes this easy. Basically there's a little knife in here and you adjust that knife so that it's just the thickness of this outside material. You clamp this on and we're just going to strip off about that much. You turn your knife 90 degrees, it cuts a slit down the side, and I actually have my knife set just a little bit shy because I don't like cutting into my wires up underneath it, but it'll peel right off like such. So really nice tool there. Now one thing I'll comment here is that this particular wire that I'm using has 4 wires in it. We need 4 wires, 3 hot and a ground. Of course the ground is green. This particular set of wires is made for 220 volt single phase, where you have a white that is a neutral. Now to make sure that there's no confusion, I'm going to change the color of this wire by putting some electrical tape on it. And for low voltage hot wires, the colors you're supposed to use is red, black, just like 220 single phase or 110 volt single phase. We have 110 volts on each one of these lines, 220 across 2 lines. But we'll take a piece of blue tape and put on here because that's your color code. Red, black, and blue is hot, and we'll do that here in just a minute. Let me get some wire cutters. I'm going to strip these back and we'll get ready to put this in. So just showing what we've done here. Here's our input line coming in. Notice I have my ground tied into the ground bus down here, and then up on the top of the fuse block we have our 3 hot wires coming in. I took blue electrical tape, turned that one to blue, red, and black. Now one thing I'm paying attention to is because I am running on a rotary phase converter, basically 2 of my legs stay hot, whereas the 3rd leg is only hot when the phase converter is on. And I've made sure that I've got my 2 lines that are always hot tied into the lines here that go to the transformer. That way my transformer is not ever getting half voltage. Whenever the machine's plugged in, the transformer's going to be hot. And I don't like having that wild leg, we call it, the one that switches on and off on the phase converter, going to the transformer. I've got my 2 good clean 110 volt lines coming straight into there, or 220 between the 2. So we've got this end all buttoned up, and I'm going to put a plug on the end, probably take the meter over here and just check a few things out, and we'll try this puppy out. All right, so we've got everything wired up. I did take my meter and just make sure all my input voltages were right. I made sure the voltages going in and out of the transformer were right. Everything checked out. Plugged it up. I've got a start-stop station here on the front. It's got an e-stop button that's broken. I'm going to have to change that out, but I'm going to go ahead and try it like it is now. I guess this is probably an OSHA requirement because we got a stop button and an e-stop button right next to one another. I'm not sure why you need both, but probably because the government said so. Anyway, we'll fix that. No big deal. Let's try it out. All right, so the bandsaw blade is going. We're going in the correct direction. If it wasn't, I would just swap 2 wires, probably on the plug, and that would fix that. And the stop button is working. So let's start that up again. Now I believe that you engage the feed. Yeah. So the actual feed for the table that moves the whole head in and out is driven off of this shaft right here, and the shaft should be turning. I believe we've got a belt problem in here, so I'm going to have to pull this belt case off the back and see what's going on there. Hopefully nothing too serious. Let's do that. All right, guys, I think I'm going to take a break on this video here. Just FYI, I pulled the belt cover off back here, and the belt is off, and I believe there's some issues with this drive system up here. Hopefully it's nothing too major, but I'm not going to try to get into it on this particular episode. I think we're just going to let this episode be on getting the new saw and doing the electrical work. We'll come in here and work on this in an upcoming video down the road. But anyway, that's where we're at right now. Good news is that the saw appears to be working in general. Like I said, we do have a little bit of an issue with the feed here, but hopefully I'm confident we can get it worked out. Just need to get in here and figure out what's going wrong and figure out what we need to do to get it taken care of. On the electrical stuff, you saw the process of switching a motor over from 440, 480 volts to 220, 240 volts, however, whatever voltage you're on in your particular location. Fairly straightforward, nothing too crazy, but does require a little bit of things you need to do. I do still need to get the proper heaters for my starter down there. I'm going to go ahead and look those up and get those ordered. I've also need to replace this emergency stop up here on my button up on the front. It's working right now, but I do want to just go ahead and put that emergency stop in there. I've actually got a bunch of electrical buttons and stuff like that over in a tub. I'm hoping that I can use one of those. I've got some e-stops over there, so hopefully we can just take one I've already got and swap that out. If not, I'll order the right one that fits that particular piece there. But that's going to be a wrap, guys. As always, thanks for watching. Please subscribe to my channel if you haven't already. Thumbs up and comments are appreciated. Hit the bell icon, leave some comments. And with that, guys, we're checking out on this one. We'll catch you on the next video. Thanks again for watching.